along with a couple of new ones as well. So I'm really excited to start teaching the class with you guys. And before I begin, I do want to just go over some maybe like introductions again. And I'm Jack. I'll be your instructor. Um, I am a CS major at University of Virginia, so I'm a college student currently. And I thought it'd be interesting for everyone to just share their name as well as an icebreaker question, just so we kind of get to know each other. For the new people. Um, the icebreaker question will be, if you could pick somewhere to visit, where would you want to go? And my answer would be, I want to go to Japan because I think they have a lot of cool technology there and also some really good food. And so when you're done, I will call on someone and then when someone goes, they can call on someone else and you can look in the participants menu. So I'll just call on the next in the list, Arjun.
My name's Arjun, and I don't know. I started Python about a year back. I actually did it a few years back, but got interested, and then I started again.
Cool. I guess we can go down the list. So next, how about Emily? Yeah, and a reminder, if you could turn on your video, it is helpful for me as well, just so I can see how everyone's doing. I can understand if it's not like you're not able to, but if you can, I would definitely appreciate it. Definitely, if you can during the introduction as well, just so we can see each other, maybe just instead of just like a black square with your name. Yeah. How about Emily? You want to introduce yourself?
I took Python 1, so like I've been to this class before.
Yeah. Just since not everyone has, I just if you could say your name and like the icebreaker or something interesting about yourself or somewhere you want to go.
I guess I like drawing and art.
Cool. And then how about Flora?
I was in Python 1 and I like swimming.
Cool. I'm actually I'm not a good swimmer myself, so it's always cool. Next is Kate.
Hi, my name is Kate, and I did Python 1 and I liked it. So I'm doing this class, and I like tennis.
Okay, awesome. Luke.
My name is Luke. I did Python 1 as well. And something I like to do is like tennis.
Awesome. So 2 tennis players here. And finally, Owen.
My name is Owen. I did Python 1 and I like reading.
Cool. Yeah, when I was in high school, I had more time and I loved reading. Like fantasy was my favorite genre to read. But it's good to hear all of you guys. And I think there is one more student that couldn't join us today, but will join us for the classes after. But that I'm gonna start sharing my screen. So a tiny bit of review because I know it's been might be a while since we last talked about Python. And so this is a really quick review question about the different loops is the last topic that we talked about, as well as some of the data structures in Python. And so here I have this variable. It's my collection because it's a collection of items. And I say square bracket 4, comma, Joe, comma, 3.14, comma, true. And so before we get to the actual question of printing out every single element, can someone first tell me what is this data structure called? What do the square brackets mean? What is this called?
A list.
Yep, great. So it's a list, which means you can add things to it, remove things, you can access elements using indexes. And notice the things inside of it don't have to be the same type. So here we have like an integer or a number. We have a string. We have like a double or a decimal value. And we have a Boolean here. So it can be whatever you want. This is a collection of items. So the question is, how would you write out some code to print out the values one by one? So this would be using a for loop. So not like print my collection 1, my collection 2. How would we use a for loop to print out every single element? So, okay, that's a good question. So I actually did want to talk. So before we used what's called, we used PyCharm as our Python IDE, but I also do want to introduce something today. Oh, okay, so I've heard of Replit. You can use that if you prefer. There's also something on the browser that I want to show off, and that's Google Colab or Collaboratory. And so for today's class, I have some code on Colab, and I'll just paste the link here. Oh, wait, that's the answer. I don't want to show that right now. Oops. Let me put that to everyone. So I put a link to a Google Colab. If you could click on it, it does require you to have a Google account. So if that is a problem for anyone, please let me know. But otherwise, you can go to this link and I can show it off. So for example, let me just log into an email account that I have. And Google Colab is a way to write Python code in the browser. And it's actually pretty convenient to use. So the way it's organized is it's in things called cells. And each cell is like a section of code that you can run by itself. And so here I have like the warm-up question. Here is the one line of code that creates my list. And so to run it, I can click on the cell and I can click the play button on the left, or I can click in the cell and do Shift Enter on my keyboard. Both work. But when I do this, it's not going to print out anything. It's not going to output because my code doesn't do that. But what you can do is you can like add another cell, and you can say like print my collection, and then it prints out the list for you. So you can write code in cells like this. Each cell can have multiple lines of code. Here, each one only has one, but you can have as many as you want in each cell. Do you want to say, when you open the link for the first time, let me show you. There's a little bit, it'll give you like a big warning. So I logged into a different account that I have. When I try to run this, oops, you can see that this notebook was not authorized by Google. This is just giving a warning because someone evil could potentially write some harmful Python code and you accidentally run it. It's just giving you a warning, but I can give you a promise that my notebooks are all going to be safe. They're fine to run. So you can click run anyways, and then you can do this on your side freely. So I will be using this today to go over the topics. If you prefer, though, you can copy paste this code into somewhere else to write code. You can use Replit, you can use the PyCharm, which we've done in previous classes. But back to the warm-up question. So here I can use the simple print statement to just print out the list like this, and I'll print out a representation of my list. But this isn't exactly what I wanted. I want to print out like 4 on one line, then Joe on the second line, then 3.14 on the third line, and true on the fourth line. So does anyone remember how to use a for loop to do this? Or does anyone remember what the basic syntax or the grammar? How do you write a for loop?
I'm pretty sure it's like for I in something.
Yep, that's great. So let me just create a new cell, or a new cell. And I can say what Luke said, the basic for loop structure is like for I in some sort of iterable, some sort of list, dictionary, a set, tuple, whatever, something that's like a collection of items. So for I in, I can say my collection. And then I need a colon, and then I need to indent my code. Colab does the indentation for you, but maybe it messes it up and you have to pay attention. But you do need to have an indent, or else the code won't run. But so you say for I in my collection, colon, and now how this loop is going to work is every time this for loop runs, I is going to change to a new value. I is going to go through each value in your list one by one. And so at the beginning, I is 4. The next time the loop runs, I is Joe. The next time the loop runs, I is 3.14. The next time the loop runs, I is true. And when you reach the end of your list, it just stops automatically. And so what we can do now is we can just say print I. Right? And if we run this code, you can see it does what we want. For Joe 3.14 true. This is an example of a simple for loop along with like a list. One thing to note, we use the variable I here, but you could have used any variable that you wanted. I is very common. X is very common. So for X in my collection, print X. X is just your variable name. So as long as it's a valid variable name, you can call it whatever you want. There was one other way to iterate through a list using a for loop, and it's a little bit trickier than this one, but sometimes it is more useful. So does anyone think they remember what I'm talking about? Hint, it has to deal with the range function, range. Okay, so I'll just give the answer because I know it might have been a while. So, okay, so the question, just to repeat, is here we showed one way to go through our list using a for loop. We said for X in my collection, print X. But I want another way of doing this using for loops. And as a hint of what I'm looking for, I want you to use the range function. And I want you to, instead of like X being each element, I want to go through each index in the array or the list. So let me create a new cell. You're still going to use a for. You're still going to use like a variable X or I. You're going to still say in, but now is where it gets a little bit different. Instead of just saying my collection, I don't want X to be like for Joe 3.14 true. I want X to be 0, 1, 2, 3, right? I want X to be a number. I want X to be the index. And so to get like a list of numbers, you can use the range function. So like for X in range 5, print X, it will print out 0, 1, 2, 3, 4. So the range function, just as a reminder, it kind of, you can think of it as it generates a list of numbers starting at 0, going up to, but not including the number that you give it, right? So here range 5 starts at 0, goes up to, but not including 5. So that's why when we print X, it goes 0, 1, 2, 3, 4. So the question is, what is the value that we want to stop at? The value that we want to stop at here is actually the length of our list. And so instead of saying like range 5 or range 10, we can say range len my collection. Right? So the length, I calculate the length of my list, I plug it into the range function. So if in this case, the length of my list is 4. So I want to do range 4. Right? If I do this, it's going to print out 0, 1, 2, 3, which isn't what I want. I want the elements in my list. And so instead of printing out X, I can do print my collection, square bracket, X, close square bracket. And if I do this, now it outputs the exact same thing as before. Right? So this is 2 ways of using a for loop to go through a list. The first is the simpler, and honestly, most of the time you can just use this. There's nothing wrong with this. Sometimes though, you're interested in the array index. And so that's why you'd use the second method. If you notice, like in this method, let's say you're going through a list and you're checking if the word or the name like Bob is in your list. So you can say for X in my collection, check if X is Bob. If it is, maybe I print I found it. However, in that sort of for loop, maybe you want to return where Bob is in your list, right? You want to know where in the list it is. If you're using a for loop like for X in my collection, that's not possible, right? You don't know how many times the for loop has iterated just by doing that. In the second method though, it is easy to figure it out because it's just X. X is the index that you're currently at, right? In this first method, you don't know what index you're currently at for X. I do have the answers kind of hidden here. So this is the first method for X and then the second one. When I wrote it up, I used I, but there's no difference what you use, I, J, K, anything works there. So that was just a little bit of review of what we did in Python 1. The other interesting thing that we did in Python 1 and what brings us to the new content of today's class is the input function from before. So before we used the input function to get user input, right? User input, you use the input function. The name does what it sounds. So here's some code that we've done in Python 1. Y equals int input, please enter a number in integer, print y. So can someone tell me, what does this line of code do? Right? If you were to explain this to someone who doesn't know Python, what would you say these 2 lines of code do?
The first line asks for what the users, what they like, the user's number, and then when you print y, it's like printing what the user entered.
Yeah. So it's a pretty simple and not very useful program by itself. The input function is right here. You can give it a message, a prompt. And so when you run this, it will print out, please enter an integer, and then it'll show you a box to type in something. We take that, whatever was typed in, we convert it to an integer because remember, by default, the input function returns a string, right? So even if the user types in like a 9, it will still return the string 9 instead of the number 9. And so to convert it to a number, we have to use this int function, which is on the outside. And then the program's not very useful. It just prints it back out. But if we go back into the Colab notebook and onto the lesson section, you can see here is the code right here. So you can ignore the comment, but you can see it's the same code as before. If we run it, like clicking the play button, you can see it says, please enter an integer, and it shows a box for you to type something. I can type like 45, hit enter on my keyboard, and you can see it prints out 45. I can run it again. I can type in 1, 2, 3, 4. Hit enter, it prints out 1, 2, 3, 4. Right. However, now if we look at the comment, it says, what happens if we put in a letter, right? This is assuming that it's going to be an integer. It asks for an integer, but you can never really control what I type, right? No one's stopping me from typing something that's not an integer, right? So if we just play around with this and run it again, You can see, let's just type my name, Jack. Hit enter and oh no, right? Like we get a lot of weird text. We get this red underline, the play button's red, we have some red text here, and it says a message in this section right here. It says value error. And then it gives you something called a traceback. It tells you what exactly caused the error. You can see there's an arrow pointing to this line. It says this line 2 caused the error. And it says value error, invalid literal for int with base 10 Jack. The message is a little bit cryptic. It's a little bit confusing if you don't know too much, but essentially what this is saying is, hey, you asked me to convert it to an integer, but you gave me Jack. How do I convert that to an integer? I don't know how to do that. And then it just gives up, it gives you this error message. Right? So in Python, in programming, this is called an exception. Right? This is an error, some error happened when you're running the code, something went wrong, you get a message. And that's what an exception is. We can see another type of error. This isn't the, this is called a value error right here, but this isn't the only type of error that you can get. If we look at the next cell, this is an example of a different type of error that you can get. You see, we have a list x 1, 4, 8, 5, 0, 11, 16, 20, and we have a for loop. We say for n in x, so this variable n is going to be every single value in your list x. We want to print out 10 divided by n, right? So we take every single number in our list and we print out 10 divided by that number. But if you are observant, you'll notice we have a 0 in our list. And probably in math class, you've learned you can never divide by 0. And so if we run this code, let's see what Python does. If we do shift enter, hit the play button, whatever, you can see we get some red underline. You can see it says 0 division error, gives you, again, the traceback. It tells you exactly what line caused the problem. In this case, it was line 4. It was this print statement that caused the problem. And then a more detailed message, it says 0 division error, division by 0. So not, I mean, it's plain and simple. It tells you exactly what went wrong. You tried to divide by 0. It's not allowed, right? It doesn't make sense to do that. So these are 2 different types of errors. There's a lot more, and we'll take a look at all the different ones a little bit later on today. But this is just an introduction of exceptions in Python. And so these are all called runtime errors, and these suspend the execution of your code. So if you notice, if we look here, you can see it printed out a couple of things before the error message showed up, right? I'm printing out n divided by 10, 10 divided by n. You can see it does it for the first 4, right? Because there's nothing wrong with doing 10 divided by 1, 10 divided by 4. There's nothing wrong with that. It's only when it gets to 0 that it causes the problem. But notice once it comes across this error, it doesn't do the rest of the code, right? It just stops. It just gives up, right? This can be for good reason, because maybe something later on depends on the line that caused the problem. So there might not be a way to continue forward, even if you wanted to. So these things, runtime errors, these are errors that show up when you're running code. They stop the execution, right? Nothing continues when you run across them. However, we can control this a little bit. We can do what's called exception handling. We can say, instead of just like throwing our hands up and saying, oh no, we can't do this, we can try to handle it in some way. And so in Python, the way you do it is you do something called a try except statement. So this is a type of statement, just like how we had if statements before. This is just another type of statement. If we look at an example right here, this is an example of a try except. You can see it says try and then it says except. So if we look at the code that's not the try except first, you can see we have a while true loop. So this is one of the types of loops that we talked about. This loop is just going to run forever unless something inside causes a problem. So it says while true, basically just do whatever's inside as infinite number of times. You're going to try something. you're going to try to do x equals int input, please enter a number, print out string x, right? And then you break. So if this all happens correctly, you're going to break. You're going to stop. You're going to stop this while loop. However, then you have this except statement. And this is where it says like, this is where the error handling comes across. It says, if you're running this code inside the try, if you're trying this code and then all of a sudden you get a value error, then you're going to do the except statement. So it says except value error, print this message, and then you don't break. So the loop runs again. And then you try again. If it succeeds, you just break. But if it doesn't work, then you go to this except statement, try again, so on, so on. So this simulates like you ask the user for some input and you just check if it's valid. If it's valid, you can continue, you can break. But if it's not valid, you just want to keep asking them again and again and again. Right? So if we look at this in Colab and run it for ourselves, it is the next cell. So here is the code that we had. If we hit run, you can see first we have our prompt. Please enter a number. So let's enter a number. Let's say we enter the number 24. It prints out, okay, here I modified the code a little bit. I'm printing out 100 divided by x. So it prints out 4.166, whatever. We entered a number, it was fine with it, we can continue on. However, if we run this again and say, I want to enter Jack, notice it no longer has red text. It no longer says, oh no, you gave me a string when I wanted a number, right? It says, okay, something went wrong. However, you told me how to handle it. You told me I should just print this thing and I should just try again, right? So I can do this as many times as I want. I can say like Bob, Joe, Alice, Eve, whatever. You can see I'm not putting in a number, but it's still handling it, right? It says, okay, I can't convert it to an int like you wanted me to, but I'm not going to give up. I'm going to keep trying. That's what the try except does. The way that this code is slightly different from the slides is that it has an additional except. And so this is like a sneak peek. Just like with if, else if, else if, else if, else if, else statements, a try except can have as many excepts as you want, in air quotes. There's really no limit on how many excepts you can have. And you can have different except statements catching different errors. So in this example, I was catching my value error. So value error, if you remember from above, that's what happened when you tried to put in a string when it was expecting an integer, right? This is value error. However, we saw the error division by zero error or zero division error. That's when you try to divide by zero. And this code also handles that one. We notice we don't say except zero division error. You can have what's called like a general except statement. If you say except without giving a specific error, it will just catch everything, right? It will just catch any error that happens. And so here, if I tried to enter the number 0, and notice if I do 0, it converts it to an integer and then does 100 divided by that number. So it's going to try to do 100 divided by 0. However, we know that's going to cause a zero division error, and we should expect to see this message printed out. So if we run, hit enter, you can see the error message is different, right? Instead of running this except, it ran the other except, right? Notice if I type in a letter, it does, oops, that was not a valid number, try again. If I do 0, it says, oh no, nothing worked, right? It's two different messages for two different errors, right? That's, for the basics, that's what a try except does. You try some code. If when you're trying it, some error happens, you just go through your except statements, look for one that handles your error, and then do that code, right? That's how a try except works. So just going back to the slides, another way to put it, first, the try clause. So everything when you say try, this section of code right here, this is your try clause, another term for it. So first, the try clause between the try and except is executed. So whatever code you had there, it just runs it. If no exception occurs, if everything is good, then the except clause is ignored. You don't care about the excepts, right? It just finishes on and moves on to the next block of code, aka whatever you have after your try except, right? It just moves on as normal. If, however, an exception occurs during the execution of the try clause, if you're running that code and an exception occurs, the rest of the clause is skipped. So just like before, it kind of stops the execution. However, in this case, it doesn't stop everything. It just stops what's ever left in your clause. It doesn't try to keep going. It stops and goes to your excepts. If the exception type matches any of the exceptions named using the except keyword, then that specific except clause is going to be run. After that's done, then execution continues like normal, right? If the exception occurs does not match any of the exceptions named, basically it's just passed on. And if you don't have any other try catch, it's just going to give you the red text again, right? So if we do this, if we go back to our code, if we remove this second except clause and run, you'll notice that now when I hit 0, it will give me red text. Right? It gives me the 0 division error, line 5, can't divide by 0. That's because we removed our except clause. If it doesn't find an except clause to handle your error, it's still just going to give you the red text like before. So you have to make sure you catch the ones that you're looking for. Right. We can put that back in, and now it handles it just like before. So you can think of it as these two lines handle when we're dividing by 0. Right. So we mentioned before that a try statement can have more than one except clause, and they can specify different exceptions. So you can have one for value error, you can have one for 0 division error, you can have one for all the different types of errors that you want. The handlers will only try to handle the exception. So only one of the handlers is going to be run. So each of those except statements is called a handler. So only one of them is going to be executed. If you have except statements that overlap, it's only going to run the first one it finds, right? Only one. And what the middle of this paragraph is saying is if you are so unlucky that in your except statement, it also causes an error, then it's just going to blow up. It's going to give you the red text. It's not going to handle anything there, right? So handlers cannot handle other handlers' exceptions. So if we look at our code, if, for example, we tried to divide by 0 here, so print 10 divided by 0, and run this again. Oh, let me stop it. Let me run. Okay. Cancel. Okay. Let me just restart the runtime. Yeah, Colab sometimes is a little bit buggy, but hopefully once it restarts, I can run this. Okay, so now what that's saying is when we're handling the value error, when we're handling if someone enters the string instead of a number, if when we're doing that, we have an error itself in the except, this is not going to be catched. It's not going to be caught by the last except clause. And I'll show you here, if I enter Jack, now it's going to say this caused an error. Like even though we have an except statement that can handle it, when you have an error inside the except, other except statements don't handle it. They just don't, they pretend it doesn't happen. They don't deal with it at all. And in this case, nothing handles it. So it just goes up to the top and gives you red text. Right? This red text is the result of not handling your errors. And finally, an except clause can have multiple exceptions inside of a parenthesized tuple, right? So we talked about tuples previously in Python 1. Tuples is a data structure where it's immutable. Once you create it, you can't add more elements, but otherwise it's kind of like a list. It's denoted by these parentheses. And so you can have an except statement like this. You can say except runtime error, comma, type error, comma, name error. So if any of these three exceptions occur, this except clause will handle all of them, right? It's only going to handle these three, but if one of those three happen, it's going to do it. Right? And then the last except clause, which we saw in the code, can omit the exception name. It can omit catching a specific exception. And this is a wildcard exception. So it's saying, whatever it is, I'm going to handle it here. Right? I tried to match it with the handlers I had above, but if it gets to this point and nothing matched above, I'm just going to handle it now. Right? It's kind of like you've reached rock bottom. This is your last resort. Try to fix it here. So in general, and when you're programming, it's fine to use this, but in general, you should only do this in extreme cases. You should try to catch the specific one that you're expecting, because if an error happens that you're not expecting and it runs into your last except, if you weren't expecting it, then maybe some code could break there. So in general, use this only with like caution, only use this if you have to. And the last statement is you can actually raise the error again. You can print a error message. You can do a lot of things here. We have an example of code here. So you don't have to understand the whole file opening system, but you can see this is another example of try catch, where we have the try, we have the try clause, the lines between try and except. And then we have our different handlers. We have IO error, we have value error, and we have the general one. Right? And each of these do a different thing. So I know I went on a long time, so I do want to take a pause right now to answer any questions that anyone might have before going on. If you're on the Colab notebook, you can play around with the code. You can try to modify it yourself. You can try to, instead of having a general except, you can try to catch the division by 0, 1 specifically. Well, actually, let's actually do that. So I said you don't want to use a general except usually. So how would we modify it? So instead of, to get rid of this general except, right? So I don't want to use this except everything. I want to accept a specific one, and I want to handle the cause where I divide by 0. So how would I modify the code? Can someone tell me where I want to type and what I should type in this cell? How about Emily? So I have right now a general except clause. This except statement is just catching everything, but I want to change it so that now it's just zero. Looks like my computer froze for a second. Hopefully that didn't cause any issues. But chat. Oh yeah. So yeah, sorry, my computer froze for a second. I have a message that says like my computer's memory is low, but I think I'm back now, so hopefully it's good. So the question is, again, I want to change this. Right now I have an except that just catches everything. This is the wildcard one. I want to change this so it catches the specific error when I divide a number by 0. And that error was, oh, it's right here. You can see the name of it is called this 0 division error. So how do I modify this code? Maybe Flora, can you help me with this? What should I do so I'm catching a specific error instead of just a general error? Okay, so yeah, so it is just the 0 division error. So all I have to do is take the name of the error, I can copy it, and all I want to do is just, instead of accept blank, I want to accept 0 division error. So actually, I have to use my keyboard. But if I run this now, you can see that it still handles the value error of typing a string instead of a number, but it also still handles the 0, 1. Right? It works exactly as before, but now instead of, it's a little bit better practice that I'm catching specifically the 0 division error rather than anything that could happen. So if we go back, that was it for the try except for right now. What we learned, you have a try statement, you have your excepts. How it works is it runs your try clause, everything in your try statement, in your try clause, these 3 lines in this case. It tries to run them. If it works fine, then you're all good. You skip to the end, right? You skip all these lines, don't do any of it, just move on like normal. If, however, a problem, an exception arises, then what you do is you go through your different excepts and check, okay, is my exception an IO error? Is my exception a value error? If not, then I'm just going to go here, right? But you can think of it kind of like an if, else if, else statement. So it's like, if it's IO error, go here. Else, if it's a value error, go here. Else, do this. Right? So I want to take kind of a pause and talk about all the different types of built-in Python exceptions. So we saw 2 of them. We saw the value error when we're trying to convert a string to a number, but the string is like Jack and it can't convert it. And we also saw 0 division error where you try to divide something by 0. However, there's a lot more types of exceptions, and I don't want to scare you, but like here's half the list of all of them. So you have kind of like a hierarchy. But you can see these are all different types of errors. Here's the 0 division error that we saw before. But in the same category, we have overflow error, we have floating point error. You can see all 3 of these are considered arithmetic errors. And arithmetic errors are under the general category exception, right? So all of these are different exceptions. I think value error is in the next slide. So this isn't even everything. The picture was kind of cut off, but here's the next slide. Yeah, down here you can see there's a value error right here. But you can see there's a ton of them, and it looks like even this picture is still cut off. So yeah, there's a 3rd one. All sorts of different types of errors. What's important to know is that there's a hierarchy. So actually there's a little bit of overlap. You can see the complete value error category here. But there's a hierarchy to it. So like you can see there's all these different types of warnings. They all fall under the bigger category warning, and warning falls into the bigger category exception. Right? So there's just like a way to organize everything. Unicode decode errors, Unicode encode errors, Unicode translate errors. These are all different Unicode errors, and all Unicode errors are value errors. Right? So it's just like a family tree, you can think of it. So I think if we go back to the Colab notebook, I have something about the hierarchy. So here's another way to look at it. You have the exception, you have all these different types of exceptions. You have value error right here, but then you also have arithmetic error, and inside of arithmetic error, you have zero division error. So these were the two that we saw before, value error and zero division error. There's a ton more. This is not showing everything. But if we go to the hidden slides, the hidden cells, you can see this hierarchy has some implications to our code, right? This hierarchy is not just some interesting fact to know. It actually has impact on when we're writing Python code. And what I mean by that is, here's two examples. So these two are almost identical to each other. The only difference is the order of your except statements. So here in example 1, we have try print 5 divided by 0. Then we have except zero division error, and then except arithmetic error. Then the second example, we have the same try and the same excepts, except now we do the arithmetic error first and the zero division error second. So can someone tell me, just take a guess, if I run these two, do you think they're going to give the same output or different outputs? Right. If you'd like, oh, actually, I didn't realize, but I guess I already ran this ahead of time, so the result is actually shown right here. The first one shows divide by 0, and the second one shows arithmetic error. So it's going to be different behaviors. The reason for this is when we come across this line and when the exception occurs, we go through our except statements. However, we go through them in order, top to bottom. So this 5 divided by 0, we know that this is a zero division error, right? So in this first case, we check our first except statement. It's a zero division except handler. So we just go under here, we do what it says, print divide by 0. And remember, only one handler is run. So we just ignore the second except and move on. So we're done at that point. We just print out divide by 0. However, if we look at our hierarchy, you'll notice that zero division errors are in a type of arithmetic error. This makes sense because like arithmetic means math. This is some sort of math error. So in the second example, we check for arithmetic errors first and then zero division error. However, this 5 divided 0, it's the most specific term for it is zero division error. However, it's an arithmetic error, so the first except statement will catch it, will handle it. And again, we only run one of them, so we just ignore the second. This example 2 is code that does not make any sense. That's because you should always have your more specific exceptions before your more general ones. That's because in this case, this bit of code is actually never going to run. It's never going to run because even if you have a zero division error, it's going to check arithmetic error first. And if you have a zero division error, that is a arithmetic error. So it's going to do this always, right? It's never going to do the second except. So that's why we care about this exception hierarchy. It has some consequences. Because this exists, the order that we check for exceptions matters a little bit. In general, though, you're going to be dealing with errors like value error and zero division error that are kind of separate and not related to each other. So in that case, you can swap the order as much as you want, and it doesn't matter. But in this case, when you're comparing arithmetic error and zero division, then it does. I'm gonna skip the part about custom exceptions because honestly, it's not that useful. I've never had to use it. But what is interesting is some extra features that the try except statement has. And this is where this will be the last bit of material we'll have today before ending class. But beyond try except, there's actually a couple other clauses that you can add on. These are optional clauses that you don't have to have, but they might come in handy depending on what you're doing. So the first one is called the else clause. It's just the same else clause in like an if else. So the else clause, when present, must follow all except clauses. This means that it must go after them in like, so you have to have all your except clauses first, and then you can put your else. The else clause is executed when no exceptions are raised. Right? So this is similar to when you have an else clause with for loops. This is kind of a similar thing. For for loops, it's run if you don't have an error. In this case, it's run when you don't have an error again. Right. So only if none of the except clauses run, then you do the else. Right. So if you do your try, you complete your try statement, and nothing goes wrong, then the else clause will run. However, if you do your try clause and an exception does occur, even if you handle it and you can move on and you don't have to stop, the else is not going to run. Right? The else is only run if you don't have an exception. So how it looks like is you have your try, you have some code here, you have your except, you run it if a problem occurs, and then you have your else. And this is what you run if you don't have exceptions. And then we have the finally clause. So the finally clause is again optional, but it's also at the end of your try. So the finally clause is always executed before leaving the try statement. Doesn't matter if you had an exception, doesn't matter if you didn't have an exception. It's always run. More interesting than that, like when I say it always runs, it always runs. Even if you have an exception that's not handled and you have all that red text, it makes sure to run this finally clause. Right? There's basically no way that this is not going to run unless you like turn off your computer or something. Right? As long as your program is running, it's going to run this finally clause. You can guarantee it. And so even when the exception occurs in the try clause and is not handled by any of the excepts, the exception is re-raised. That's what causes the red. But it's only re-raised after the finally is run. Right? So again, it's always run. That's the only thing, that's the main thing that you have to know about the finally clause. Another way to describe it is the finally clause is executed on the way out. Right? So when you're done with everything, on your way out, you do your finally clause. Oftentimes, this is used to like clean up after yourself. So maybe you have a program that's messing with some files. The finally clause just makes sure that you're closing all your connections, making sure that you're not like leaving any traces. You just clean up after yourself. So you can understand you want to do that whether or not you had an exception, right? Maybe you had an exception and you had to stop halfway through. You want to make sure you don't like mess like with the file. Like maybe you want to restore it to the previous state. Maybe you want to do something before you stop. But it's like, that's what you'd use a finally clause for. So if we add this to our diagram from before, we have our try, we have our except, we have an else, and at the very end, you have your finally. So again, you try to run this code. Maybe it works, maybe it doesn't. If it doesn't work, you do the except, or you try to do the except. You look for an except clause that matches whatever problem happened, and you do whatever it tells you to. If you're running the code and you don't have an exception, then you skip the except and you go to else, right? If you have exceptions, you go to except. If you don't have exceptions, you go to else. But no matter what, whether you have exceptions, whether you don't have exceptions, at the end you go to finally, and then you move on, right? So again, else and finally, these are optional, but try and except are required. So if you have a try, you have to have at least one except clause. You can have more, but you have to have at least one. The else and finally, you don't need to have them. You can't have more than one though. So you can have 0 or 1, but you can't have like 2. Right? So I have a couple of questions. So these are some really quick quiz questions. So I'm gonna post this for you to look at, and I'm gonna make a straw poll really quick. So take a look at that, and let me make a straw poll. So ABC. So when you think you have an answer, I put a straw poll link in the chat. So if you click on that, you can select what answer you think it is, and we can take a look at it together.
It's not
So-
loading for me.
Oh, is it? Can you not see the slides, or is the website not loading?
I can't see the share screen. It just says your use has started. Oh wait, never mind. I can see it now.
Okay. My bad. Okay. So the question is, how many accept statements can a try except block have? So is it 1? Is it 0? Is it 0 or more? Or is it 1 or more? So I'll wait for a couple responses, but I have a couple of these, so we're also running at the end, close to the end of time, so I don't want to take too long each question. So how about in the next 30 seconds, let's try to get an answer in. Again, straw polls mean they're anonymous, so if you're not sure, you can make a guess. No one knows what you put. Not even I know what you put, so feel free to just make your best guess. Okay, so I'll go over the answer now. So the answer to this question is D. So the number of accept statements is variable. So there's no like limit. So immediately you can cancel out A and B. Those are not the right answer. The only question is, can you have 0 or do you have to at least have 1? And so we just said accept statements are required. You can't have 0. If you have a try, you have to have an accept. So the lower limit is 1. The upper limit is whatever you want it to be. So the correct answer is D, 1 or more. So since in the interest of time, this is the last question I'll go over. But again, I want to take a little bit of time. And this time I will call on someone after a minute is up. So you don't have to worry about the formatting since this is on PowerPoint. The lines don't work out the best. But calling someone, how about Owen? What do you think is the correct answer to this question? What is going to be printed out when you run this try except finally? If you're not sure, you can also just put in the chat that you're not sure. And we can go over it. Okay, so you think it's D. D is the correct answer. That's great. So if we look at this code, the try clause is just a single statement, print try. This clearly does not throw any exceptions. So this except clause is not going to be run. However, we have a finally clause, and we said before, finally is always run. So it's going to print try, and then it's going to print finally. But it's not going to print out value error. So the correct answer is D, it's try finally. So that's it for the material. So just in the interest of, well, getting the course logistics sorted out, I have these materials posted on Google Classroom. So it is actually posted now. And you can see that, oh, okay. Well, if you go onto Google Classroom, you should be able to see this. You should see the slides for today, as well as the Colab notebook if you want to play around with that later. And we also have a simple or a quick homework assignment. So this is very similar to one of the examples on Colab. So you might want to take a look for that. But what I want you to do is write a Python program that takes in 2 numbers from the user using the input function, convert them into integers using the int function. I want you to print out the result of x divided by y. Right? So the first number is x, the second number is y. Of course, we just learned about error exceptions, exception handling, and this simple program can have several exceptions that happen. Maybe y is 0, maybe you didn't type in a number. You want to handle these. And so the last part is just adding the try except to handle all the different errors. So at the end of the day, I want a program that is always going to run correctly. It's never going to give you that red text. Right? So that's the homework assignment. It's pretty similar to one of the Colab cells. So take a look at that if you're not sure where to start. Google Classroom, if you're not on there yet, we do have a Google Classroom, and this is the code, which I'll leave on the screen and also put in the chat. But this is where all the material is going to be posted every single week. But with that, that's all material I have for today. Sorry for going a little bit over. I'll try to stay on time in the next class. But yeah, had a great first class, and I'll see you all next week. If you have any questions, you can stick around and I'll answer them. But otherwise, have a good week.